thiocyanate ion, SCN minus. Well, here we have three Lewis structure representations of the polyatomic ion. Going from left to right, one structure has two double bonds with the central. The next structure has a triple bond between nitrogen in the central and a single bond between sulfur in the central. And then the third one flips it around. It has a triple bond between sulfur in the central atom and a single bond between nitrogen in the central atom. So remember what we did with carbon dioxide. The best Lewis structure was the one that had more zeros in the formal charge. Well, we have to calculate the formal charge for all of them. And let's see what we have. And this is not the Lewis structure to start with if you haven't done formal charge before. If you haven't done formal charge, you need to go back and do the carbon dioxide problem, because I take a little more time to go through that one. And for this one, I'm going to just present the formal charge for each atom in each species without giving a detailed explanation. Starting on the left, that sulfur has a formal charge of 0. The central carbon atom has a formal charge of 0. And then the nitrogen atom has a formal charge of -1. Now let's double check. The formal charges have to add up to the charge on the species. The thiocyanate ion has a negative charge on it, so we have a 0, 0, -1. That adds up. Let's go to the second structure. That sulfur has a -1 formal charge. The central carbon atom has a 0 formal charge. And the nitrogen atom has a 0 formal charge. -1, 0, 0 adds up to -1. Okay? The rightmost structure. That sulfur has a +1 formal charge. The central carbon atom has a 0 formal charge. And nitrogen has a -2 formal charge. +1, 0, and -2, those add up to -1. All right, so out of these three structures, we see the first two have 2 zeros for formal charge and then a -1. This rightmost structure has only one formal charge equal to 0. So for a first pass, we can eliminate the rightmost structure because it has fewer formal charges equal to 0. Now out of these two, this is a little harder to compare because each has 2 zeros and then a -1. Look at the two atoms that have a -1 formal charge on them. Nitrogen and sulfur. Now if you go back to the definition of formal charge, the calculation is independent of electronegativity. But when you get to this point, if you have to do this kind of a comparison, you now have to use electronegativity. Yeah, I know. That's just one of the problems with formal charge. There's nothing perfect. For this comparison, you pick the structure then that has the lowest formal charge, I should say the more negative formal charge on the more electronegative atom. So the one on the left has the -1 on nitrogen, the one on the right has the -1 on sulfur. So take a look at your electronegativity table and which of those two atoms has the greater electronegativity. Well, that would be nitrogen. Nitrogen's electronegativity is greater than that of sulfur. Therefore, the leftmost structure is the best Lewis structure out of those three.